So today we are working with direct variation. It's going to be very similar to yesterday. A essential question is, what steps would you take to determine whether or not an equation has a constant of variation? Vocabulary is direct variation and constant of variation. What does variation mean?
A type of something.
Okay, you guys have a really good idea. There's different types of different things. But what if I say, if Mr. Disco was to come in and ask me how my classes were doing, it varies. What do I mean by that? It's different. So, but a direct variation that also can relate back to change, right? What did we work on yesterday? Scope and what was the title?
Constant.
Constant rate of change. When I say that my classes vary from block to block, that means it changes. Something about it changes from block to block. A variation is very similar to a change. So if I'm talking about constant of change, or the constant rate of change and a constant variation, they're very similar. Okay? In fact, I'll be honest with everyone, I don't know why we need two lessons on this. I don't know why they have to be separated. It's weird. But we want to talk about it. So first we got to talk about that direct variation. What does direct mean?
Forward. Straightforward.
Straightforward. It's very obvious. Okay. So a direct variation, what it does is when the ratio of two variables is constant. What that means is when the ratio of the two variables is constant, that means that every single XY pair we get when you put Y over X or Y divided by X will always equal the same number. It's a little bit more than that. It's actually saying, let's take the ordered pairs of let's say we have those four ordered pairs. When the ratio of two variable quantities is constant, the ratio is always going to be put as Y over X every single time. So look at the first ordered pair. Which one's the Y?
6.
What is 6 over 3?
2.
Look at the second one. What's the Y? 8 over what?
4.
Omen, make sure you're paying attention. What does 8 over 4 make?
2.
What about the next one? 10 over 5 is?
2.
What about the last one?
2.
24 over 12 is? What can you tell me about all those ratios? What that is telling us is the constant rate of change, or the constant in this is 2. Okay, so this 2 is the constant rate of change. But here's what else we need to know. In our direct variation, the graph always passes through the origin or 0, 0. Every single time. If it is a true direct variation, you're going to hit the origin. Okay? Any questions on that? All right, so we have an equation. This equation that we're going to work with, and this is exactly why I wanted to teach equations before any of this kind of stuff, because we're going to work with equations from now on. We have the equation y equals mx. Y is the dependent. X is the independent. M is the constant rate of change. Or the slope. Okay, what that means is you guys just found the slope. On these ordered pairs that I put up here, how you would write that in an equation form is y equals 2x. Any questions on that? Let's turn to the student page. Yes, Max.
What would it equal to X?
I'm talking about these ordered pairs up here. Okay? Does it make sense now that you know what ordered pairs you're talking about?
Yeah.
Okay, so these ordered pairs that we've already done, each one, when divided, equals 2. That tells us that x times whatever we got will equal y every single time. So you can write their equation. All right? Any other questions? Okay. Student page. So on the student page, I want you guys to write down these ordered pairs. 4, 14. 8, 28. 12, 42. I don't go with those. We're going to find the direct variation. You are going to write an equation. Your equation, what is it always going to look like? Look back on your teacher page. What is the initial equation I gave you? You are always going to have y equals mx. The only thing that needs to change on this is the m. You have to figure out what m is. M stands for the slope. M stands for the constant rate of change. M stands for direct variation. If it is a direct variation. So let's write an equation. You guys remember how to find M?
Yeah.
How do we find it?
You put Y over.
Y divided by X is going to equal M. So what is the first Y?
14 over 4.
14 divided by 4 equals 3 and 2/4, which equals what? You could do it that way, that is true. But here's the thing, with slope, let's keep it improper. So instead of going that route, what can go into both 14 and 4?
4.
Can go over into 14? Yeah, let's divide it by 2. What's 14 divided by 2?
7.
What is 4 divided by 2?
2.
There you go. Leave it as improper. Okay? So let's try the next one. What is our next ordered pair? 28 over 8. What can go into both 28 and 8?
4.
Let's divide them both by 4. What's 28 divided by 4?
7.
8 divided by 4.
2.
What's our last ordered pair?
7 over 2.
What's our last ordered pair?
42.
42 over 12. What can go into both 42 and 12? 42 divided by 6? 12 divided by 6? Are all of these the same? So what is your slope or your constant rate of change or your direct variation? So to write an equation, you have y equals 7 to x.
Will there be a time where they're not all the same?
Yes. There could be one that's not all the. Are those what?
Are those difficult?
It's a self-fulfilling.
Not really. Let's try this one. 15, 6, and let's do 39. And let's do 45, 12. We're still trying to get that y equals mx, right? Okay, what's our first ordered pair?
6 over 15.
6 over 15. Can anything go into both 6 and 15? What do we get? Let's do our next one. What is it? 9 over 30. What can go into both 9 and 30? 3. What's 9 divided by 3?
3.
And 30 divided by 3?
Yeah.
Are those the same?
Oh.
There is no direct variation.
What's that other one?
Why is there no direct variation?
Because they're not all the same.
Which means it has no
Constant slope.
constant rate of change or slope. Or it does have a slope. It does have a slope, but it has no constant. So we'll say we have no constant variation because each one changes. Because if you were to take 45 and 12, what can go into a 45 and 12? Try it again. What? And 6 going? No.
No.
So that equals 15 over
4.
6 That can be simplified by 3, which makes it 5 over 2.
Wait,
Look at this.
what's one of my
That's
three, six?
2 over 5 and then like 3 over 2 and 5 over 2.
Oh, I wrote that backwards.
No,
I wrote that backwards. I apologize. This one would have been 12 over 15, right? Okay, divided by 3 equals 4 over 15. Sorry, I wrote that way wrong. Thank you for, saying it so confused like that. Are those two the same? So there's no constant variation.
So basically, you don't have to solve the other ones. You already know one's wrong.
Yep, as soon as you get these two, they're different. There is no constant variation. There is no direct variation. Huh? Yeah, if I give you 5 ordered pairs and you find 2 of them that do not equal the same, it is not a direct variation. If the first 2 have a different ratio equivalency, no direct variation, none. So you just have to solve them until you find all of them are the same or until one of them is different.
So
Okay.
basically putting them over each other, but instead of subtracting, you divide. And
Yeah.
simplify.
Alright, so you want to see what's so easy about this?
Everything. Just kidding.
Here we go.
It's super hard.
Let's see. If I give you this, what is the direct variation?
40.
Direct variation equals 40. That's simple, right? What if I give you something? Make sure I was reading that right. Like that.
Oh, no.
Want to know why? That plus 5 threw us off. If you add anything to that y equals mx, there is no direct variation. There's nothing there. Can't use it. So it's either y equals a number times x, you have direct variation, it's the number given, or it's y equals a number times x plus a constant, and because of that constant, there is no direct variation. This constant actually changes how we graph it. This constant means it will not go through 0, 0. Plus 5 means it starts at 0, 5. If it starts at 0, 5, do you hit the origin? No. You've already gone past it. You've already missed the mark. You're done. Okay? Any questions on that? All right. Guess what? Homework.
Let's go. 307 already?
Yep. 307 already, and it's time for your homework.
So fast.
It is all online.
Online time.